Good afternoon to all. I'll share with you the results of the vaccination trial we did in Conakry to evaluate the immunogenicity of a second delayed dose of cholera vaccine. Oral vaccines against cholera are widely used to control epidemics.
Le vaccin procure cependant une protection partielle.
But it gives only partial protection, particularly in young children. The standard schedule is a 2-dose, 2 weeks apart, which means many constraints, because then you have to organize 2 vaccination campaigns, one very close to the other, and operationally it's difficult to apply on a large scale, particularly in an emergency situation. So the second dose, when it is given, it's often after a longer time than recommended. And then the OCV stockpile is limited. In 2022, there was a shortage, so we adopted a temporary strategy was adopted, a single dose in epidemic context so as to maximize the overall coverage of the population, even though without a second dose you have a shorter term protection. But in areas where there's still a risk of cholera, the second dose, even delayed, is absolutely essential for longer term protection. Finally, more and more data suggests that the 2-week interval between the 2 doses might not be the optimal vaccination schedule or regimen, and it might be too short to reinforce the immunity memory, which is essential to ensure long-lasting immunity. So we wanted to evaluate the induced immunity response with a second dose of oral vaccination delayed and compare it with the standard vaccination schedule.
Nous avons réalisé un essai d'immunogénicité.
We did an open, randomized, and controlled immunogenicity trial. The aim was to demonstrate the non-inferiority of the immune response between the participants getting a second dose of OCV, pre-qualified Euvichol-Plus, that was, 6 or 12 months after the initial dose, and other participants getting a second dose of Euvichol-Plus only 2 weeks after the initial dose, as it is recommended. The main indicator for the immune response was evaluated on the basis of the geometric mean in the title of the antibodies, serum antibodies, at 14 days after the second dose of vaccine for the serogroup 01 and the serotypes Inaba and Okawa of 01, which are both covered by Euvichol-Plus. So I will present you the results. The study was in children under 1 year old to 9 years old and from 1 to 4. We had several secondary objectives comparing the seroconversion rates, the measurement of other antibodies that are specific of cholera, and the evaluation of the in the kinetics of the immune response in adults. The tolerance was also evaluated, even though we have a profile. So Conakry, Guinea, the latest Ogawa serotype epidemic dated back to 2012. The main eligibility criteria to take part in the trial was to be aged between 1 to 39-year-old, to belong to the general population, and to be in good health. Please note that not pregnant or pregnant and lactating women were not included, couldn't be enrolled. The evaluation of non-inferiority rests on the ratio of the geometric mean of the main indicator. So we will compare the level of vibrioside seric antibodies 14 days after the second dose of VCO or OCV between the groups getting a second delayed dose 6 or 12 months later and the control group getting both doses according to the standard regimen, which is 2 weeks apart. So the ratios compare the importance of the immune response in participants getting a second delayed dose of OCV compared with the group getting the 2 doses in the standard regimen. the inferiority margin is 0.67. That is the
Le schéma vaccinal à dose retardée
the
serait 2/3.
so it's two-thirds the immune response with the delayed dose is two-thirds of what it is in the standard regimen. So the non-inferiority could be demonstrated if the lower bracket of the confidence interval around that ratio is not lower than this margin. In other words, if it's above 0.67, and the criterion should be filled for the both Inaba and Ogawa serotypes with a power of 80%, 20% loss to follow-up or failure in doing the analysis. Our sample was supposed to include 152 participants per arm, randomized individually according to an equal ratio in the three arms of the study and three age groups, 1 to 4, 5 to 15, and 15 to 39 years of age, so as to have an even distribution of ages in the trial compared with the general population in Conakry. Between July 22 and February 23, we evaluated the eligibility of 501 participants until we reached the required sample size of 456 participants who were randomized between the three arms. The latest visit of the last participant took place in August 24. The population with the intention of being treated included all the randomized patients who had received at least one dose of OCV and who had at least one blood sample taken after the first vaccine dose. That was the majority of the participants. The population, according to the protocol, included all the people who received both doses of OCV and who had a blood sample taken 14 days after the second dose, according to the protocol schedule. It represents respectively 96%, 90%, and 86% of the three trial arms, which is a good retention rate of the participants, even though it goes down with time. 47 of participants were under 15 years of age, 48 were women, 45 had an O blood group, blood type associated with a higher risk of cholera, and none of them declared or reported being HIV positive. The geometric means of the serum antibodies were comparable between the three arms of the trial. At the time of the inclusion, the geometric means of the same antibodies tended to go up in the groups with a second dose delayed for Igawa and Onaba types, and those are the values that we'll use to compare the non-inferiority of the vaccination schedules with the second delayed dose. The ratio of the geometric mean and the confidence interval to demonstrate non-inferiority. The lower part of the confidence interval of the ratio should be above the inferiority margin, so it has to be above 0.67. And for all the participants aged 1 to 39, it was the case, both for Inaba and Ogawa serotypes. In the group getting a second dose after 6 months, as well as in the group getting a second dose after 12 months after the first one, and both among the population that we intended to treat or per protocol population. On this graph, you have the results for children aged 1 to 9 years of age, and you can have the same interpretation for serotype O1 for those children. And those data are for children aged 1 to 4, and same interpretation, despite the fact that the sample size is quite limited in this age group. Those results show that the vaccination schedules with 6 or 12 months apart between the two OCV doses immunologically are not inferior to the standard regimen, which is a 2-week interval for the serogroup O1 and the major serotypes Ogawa and Inaba. Longer intervals between the two doses of Euvichol-Plus are a viable alternative to the conventional regimen. It could even promote a better immunity memory, therefore ensuring longer-term immunity. Those results match the observations of previous studies on the immune response after a second delayed dose of OCV. It was done in Cameroon or DRC and India. So our results reinforce that with solid evidence, encouraging a strategy of a single dose, more flexible with longer intervals between the two doses when you have epidemics. That's for serogroup O1. And the initial response is based on a single dose strategy during outbreaks, and the second dose will be delayed without compromising immune protection on the longer term. Many thanks to the people who took part in that study.